Hello and welcome back. Okay, so what do we have here? First of all, we learned that the movement of negative charge carriers, which are electrons are negative charge carriers. What are positive charge carriers? Protons. All right, so the movement of negative charge carriers is known as current. Current is measured in what? Amperes. Current is measured in amperes, okay? Current is measured in amperes. So, how do we get that movement? How do we get that flow? We can't just put a resistor and tie its two ends together, right? We won't get anything, right? Everything's just stable there. We need a potential difference, okay? Whether that be a chemical potential difference, which you'll get from a battery, or you'll get another potential difference from moving two pieces of metal together, like we do in an hydroelectric power plant or wind turbines, okay? Moving two pieces of metal together. But potential difference, okay? Potential difference needs an electromotive force, okay? That electromotive force, that force comes from a battery. Again, a chemical potential difference, all right? Battery is measured as a potential difference. So that's exactly what we're going to put. Electrical potential difference. Electrical potential difference is volts. Okay? That's our new thing. Electrical potential difference is volts. Once that voltage or electrical potential difference, once that moves a charge, that creates work. Okay? Work. Work is measured in units of joules. Okay? Work is measured in units of joules. So what we have here is voltage times charge is equal to work. Okay? Which work is also equal to, as you've seen in your slides, force times distance. What is force? Force is mass times acceleration times distance. That is another form of force. Force is also Coulombic force. Okay? If you move something electrically, you could also use that F right there and replace this F with that. Okay? So, what did we talk about? We talked about in order for a current to exist, in order for a movement of charge to exist, to happen, you'll need a potential difference. Okay? You'll need a potential difference. That potential difference comes from an electromotive force, which is a battery, it's one form of it. EMF, electromotive force, we relate that as V. You'll see that in schematics sometimes. Current is measured in amps. Work is measured in joules. Electrical potential difference is measured in volts. Sometimes we say voltage for simpler. Volts times charge is equal to work. Force times distance is also equal to work. Okay? And that is that. That wraps up our second chapter, I believe. Let me see. Yeah. So like charges repel each other. Like charges repel, unlike charges attract. Electrical properties of atom depends on the configuration of a negatively charged electron. So electrons are what moves. So if you have a negatively charged system, it has an abundance of electrons. Okay. If it is a positively charged system, it lacks electrons. Okay. The outermost electrons in an atom are the ones that become the free electrons, and electrons are negative charge carriers, okay? Electrons are negative charge carriers, so the movement of those free electrons creates a current. That current is measured in units of amps, okay? 1 coulomb is equal to 6.24 times 10 to the 18 electrons. That's a lot of electrons, but electrons can move awfully fast, and a lot of them can be packed into one wire, so that's not a whole lot, okay? All right, so electrical potential difference is measured in volts. We need a volt, and we need potential difference in order to create an electromotive force, which comes from one source of that is a battery. Voltage can create work, okay? Electrical potential difference alone, sitting alone like a battery, just holding it in my hand, will not do anything. But connecting it will have a differential charge, and that charge will create work. Okay, thank you very much, and we'll look forward to more videos.